Hi, Assalamualaikum. How are you today? So today we are going to look into the one sensors that is ultrasonic sensor, which is being widely used in measuring the distance between the robot and obstacle. Okay. So what did the sensor do? The main function of the sensor is to measure the distance between the sensor and the object or obstacle. So this is how the sensor look like. Okay. So in this application, we are going to use the sensor with a series of HC-SR04. So these are the features of the sensor. Okay, it is operated at the voltage of 5 volt, and then in theoretical, it would to measure a distance between 2 centimeter to up until 450 centimeter. But in practical or in actual practical, the measured distance is limited from 2 cm until 80 cm. This is actually basically based from previous experiments that has been done by others. Okay, the accuracy of the measurement is around 3 millimeters, which is quite accurate. Okay, and then the measuring angle of this sensor is 15 degree. While it is operated with the small current, and then the operating frequency is 40 kilohertz. Okay, so it's actually 40 kilohertz. All right. So as you can see here, the sensor has 4 pins. Okay, the first pin is the VCC, then second pin trigger, the third one is echo, and the last one is ground. So the VCC pin, you need to connect it to a voltage source of 5 volt, and then the trigger pin is the input pin of this sensor. Okay, and then this pin has to be kept high for 10 microseconds to initialize the measurement process. Okay, to initialize the measurement by sending the ultrasonic wave, right? And then the echo pin is is the output pin of the sensor, which it will go high for a period of time which will be equal to the time taken for the ultrasonic wave to return back to the sensor. Okay, it will compute the time, it will measure the time for the sensor to transmit the sound wave and then to receive the reflected sound wave. And then the ground pin, you must connect it to the ground of your system or your circuit. First of all, we need to look the theory behind of this operation. Okay, so let's say you are placing a sensor in front of an object. So we need to know how does the sensor measure the distance between its location and the object. So there are a formula that has been used in this measurement. The formula is a direct formula, which is a distance formula. So the distance formula is equivalent to the speed times with the time. Okay, so speed here is the velocity of the sound wave in air, which is approximately to 343 meter per second. You can see here there are 2 delay or 2 time is captured, okay, during this operation. When the signal is transmit from the sensor towards the object, so there is a delay here, and then this delay we call it as a TT. Okay, and then when the signal hitting the object, the surface of this object, and then it will be reflected back to the receiver here. Okay, and then there is a delay here, and then this delay is called STR or reflected time. Okay, and therefore this equation can be elaborated in this equation. Okay, so the time here is actually TT plus TR. Okay, but why we need to divide by 2? Because time delay for the transmit signal for the transmitted signal is equivalent to the reflected signal, okay, because this is the same signal, and then the time taken here and then the time taken to be reflected back to the sensor is same, okay, and therefore you can divide it by 2 to get a distance. So now we look into the timing operation of the sensor. First step is you need to give the trigger pin some pulse here, okay, and then the width of this pulse is 10 microsecond, okay, and so that when the sensor receive this signal to start the measurement, okay, so when it receive the signal, so it will start sending the sound wave, okay, so there are 8 pulses here, okay, 8 pulses sent in the sound wave with the frequency of 40 kilohertz. Okay, once it hit the object, so this signal will be reflected back to the receiver. The echo pin at the sensor will start measure the delay. Okay, so once this the signal or the sound wave is transmitted, the echo will start count. Okay, it will start count the delay here. And then when the receiver receive the reflected signal, the last reflected pulse here, so it will stop the counting. Okay, and therefore the delay here is actually TT plus TR. Okay, so this is how the sensor measure the time of flight of this sound wave signal. So now we already have the duration of the time of flight of that sound wave signal, but what is the equivalent centimeter for that signal? And therefore we need to do some conversion. Okay, so this sensor will give you time in microseconds. Okay, and therefore you need to convert this microsecond and then you will get the centimeter. So first is you need to convert the speed of the sound to centimeters per second, okay, because the original one is in meter per second, okay, and therefore 343 meter per second. This is the velocity of the speed of the wave, and therefore you need to convert this one into centimeters per second. And then later, once you have converted it, you need to convert the seconds, the second here, into microseconds. Okay, let's try. So first step is you need to convert meter to centimeter or cm. Okay, so we have 343 meter per second. So meter convert to cms, so you have to times with 10 to the power of 2, and therefore the converted value is okay. Next one is this sound wave speed, you need to convert it to microsecond, right? Because the sensor will give you a delay in microsecond, and therefore second, if you want to convert to microsecond, you need to times with 6, right? So it will become 1 times 10 to the power of 6, it will become microsecond, and therefore from here okay, cm to microsecond. So here you convert to microsecond, you will get this one. So now it will become microsecond. So now the new value is this one, you can cancel it, this one becomes 4, and now the new value is 343 times 10 to the minus of 4 cm per microsecond, or equivalent to 0.0343 cm per microsecond. So you are going to use this value to convert the duration of the time delay, okay, into distance. So now we are going to write the code in the Arduino, but you need to follow these steps. The first step is you need to set the trigger pin low for 2 seconds or 2 microseconds, sorry. And then you need to set the trigger pin to high state for 10 microseconds because you want to acknowledge the sensor to start measure the distance. And then after the pin has been high for 10 microseconds, then you need to set it back to the low state. After this process has done, then you need to read the echo pin, or you get the duration of the time of flight of that sound wave. After you get the duration, which is the TR plus TT, then you convert this duration into distance in cm, okay, by using the conversion just now. So we try the simulation through the Tinkercad, okay.